When a distribution has a few extreme scores, scores that are very different in value from most of the others, then the mean may not be a good representative of the majority of the distribution. The problem comes from the fact that one or two extreme values can have a large influence and cause the mean to be displaced. The median is not affected by extreme scores. Occasionally, you will encounter a situation in which an individual has an unknown or undetermined score. It's impossible to compute the mean for these data because of the undetermined value, but it is possible to compute the median. A distribution is said to be open-ended when there is no upper limit or lower limit for one of the categories. It's impossible to compute a mean for these data because you cannot find the sum of x. However, you could find the median. When scores are measured on an ordinal scale, the median is always appropriate and is usually the preferred measure of central tendency. The primary advantage of the mode is that it can be used to measure and describe central tendency for data that are measured on a nominal scale. Recall that discrete variables are those that exist only in indivisible categories. In many situations with discrete variables, the mode is the preferred measure. Because the mode requires little or no calculation, it's often included as a supplementary measure along with the mean or median. The value of the mode or modes in this situation is that it gives an indication of the shape of the distribution as well as the measure of central tendency. Examples of situations where one might have a distribution with undetermined values or open-ended distributions are outlined in section 3.5 of your textbook. This figure 3.10 on page 81 in your text, shows examples of three different kinds of distributions, all of which are symmetrical: normal, bimodal, and rectangular. For a symmetrical distribution, the right-hand side of the graph will be a mirror image of the left-hand side. By definition, the median will be exactly at the center of a symmetrical distribution because exactly half of the area in the graph will be on either side of the center. The mean will also be exactly at the center of a symmetrical distribution because each score on the left side of the distribution is perfectly balanced by a corresponding score, the mirror image, on the right side. As a result, the mean, the balance point, will be located at the center of the distribution. Thus, for any symmetrical distribution, the mean and the median will be the same number. If a symmetrical distribution has only one mode, it will also be exactly in the center of the distribution. In this case, all three measures of central tendency, the mean, the median, and the mode, will have the same value. On the other hand, a bimodal distribution that is symmetrical will have the mean and the median together in the center with the modes on each side. A rectangular distribution has no mode because all the x values occur with the same frequency. Still, the mean and the median will be in the center of the distribution and equivalent in value.